First, let's just start with a little review here. Reminder from a long time ago. What you did was you needed to multiply, simply distribute within the parentheses. Okay? This could be done using this box method. Didn't have to be used, but one way of showing it. And the main reason for wanting to do it this way, main reason right now for wanting to do it this way is that what we're really going to be focusing on is doing this whole process backwards. So right now, it's simple multiplication, which is 3 times 5, a, and 5 times 3a is 15, and 5 times 8. So that's all it was. And we can do this process backwards, which is the opposite of distributive properties is called factoring. And this is the worksheet we did in class last week. So we can do something similar, but yet work backwards. Instead of multiplying in, divide out. We had to figure out what number comes out of 15 and 12. In this case would be 3 as well. And then 3 times what is 15x? And 3 times what is negative 12? So we can do the same process using this box forward or backwards. And that was what you guys did last week already. You got down here, it says, okay, we can factor that as well. Break it up into multiplication. What number goes into 10 and 50? 2, 5, and of these, which one did we actually want to use? 10. Okay, so we said this is the common factor. That was a common factor. So 10 was the greatest common factor. So whenever possible, use the GCF. Even though 5 goes in there, we want to use 10. And this will make everything much easier to solve later on. And again, we can work backwards. 10a times what is 10a to the 4th? And we can get our 10a times what's negative 50. We can get our factors. 10a is a factor, and so same process, just working it backwards. Working it backwards. And then lastly, we said we can also factor. We have 4 terms. That's nice too. We can easily just throw it into the box, but we add a new layer right here. Before when it was up here, now it takes up another layer. And we'll throw in the terms, 1 per box. So we always have 4 terms. And it worked kind of the same. You had to find the GCF of each row as well. GCF of this row. They don't have any numbers in common, but they do have a F in common. This row has 5 and it has 40. So together they have a 5 in common. But this has an n to the 3rd, this has an n to the 2nd, so they both have at least an n to the 2nd. So if you went through and found the GCF each row, each column, it should work out that, what you come up with, multiplies back together. So n times 5n squared equals that. So there's 2 ways of getting these answers. So you always have a way to check. n times what is 2n? N times what is 2n? And 2 times what is 16? 8. Positive. And of course, 8 is also the GCF of these two. So it works both ways. I could have just said, what's the GCF of this column got 8? Or I can say 2 times what is 16. So in every single way, they always should work. Alright, so we've got our answer here. So 5n squared. And of course, I could switch the order here. I could put n plus 8 first, and then 5n squared plus 2 second. Could do that. Oh. So that's what we've done so far. If you go back to 7, if you're here, and we'll move on. Okay. If I have this, I can simply multiply these together. Negative 48 x to the second. This will be 7 times 6x, 42. This will be 8x times 4, negative 32. This will be 7 times 4, 28. So we get 4 terms, right? However, the diagonal should come together. Those are like terms. So I can combine them. Now the question is today and tomorrow, how do you do this problem right here backwards? How do you do this right here backwards? So if I give you this, how can you put it, how can you go backwards and say, well, that 10 is going to be 42 minus 30? How come it wouldn't be like 12 minus 2 or 15 minus 5? How do you know that this 10x should be broken up into 42x and negative 32x? Okay. So it's one thing when I give you 4 terms, like I did here. I give you 4 terms. Oh, it's simple. 1, 2, 3, 4. 4 boxes, 4 terms, no big deal. But what if I give you only 3 terms? You still have 4 boxes you have to fill up. You don't have to break this up into 2 parts so you can fill in all 4 boxes. That's to do with we have a trinomial, 3 terms. How do you work backwards to still factor it? It's going to look somewhat familiar. Let's get into it. Okay. Here is a setup for a basic problem that you'll be practicing 14 times over for your homework tonight. Go ahead and copy that down. Everything you see up there, every part of the problem. Copy down the 2x squared plus 9x plus 10, the a, b, and c above it. This x right here with the words above and below it. The box with the letters inside and the terms inside. Everything you see up there, go ahead and copy that down. And this will be your guidelines for your homework and how to do all your problems. Okay. Again, we use this when you have a trinomial. As the homeworks earlier, when you factored, you had 2 terms, you put it in the box. Or they had 4 terms, and you had a new row, and you put it in the box. We're looking at the middle. What happens when there's only 3 terms? You have 4 boxes still to fill up, but you only have 3 terms to start. That's when you use this. So it's important to know. Not only how to do this, but when to do this. It doesn't mean we forget everything we did earlier and do this method today, now on, and everything. This only applies to certain problems. And the new problem today is there's a trinomial. There's 3 terms. Have 3 terms to start. You know what? Our box requires 4 terms. So how do we get 4 terms if we're starting off with only 3 terms? We can figure out how to get that, then we can do exactly what we have been doing. As you can see, the box is it's halfway completed already. You can see the first term is still in the upper left-hand corner. The last term is in the lower right-hand corner. So that part hasn't changed too much yet. Missing. All the way down. Words and everything. Draw the arrows. So you can see that there. And also, as we're going through this, you might notice Of course, you've done this before. Took algebra last year or last semester. You've done this before. Yeah, you've done this before. This might look like more writing than you've seen before, but ask yourself, when you did do this, did you get 100% on every single problem? If not, then you want to switch to this. What I don't want you saying is, I've already done this, that means I already know how to do it. That means I don't have to really do anything I'm being shown today. That's optional. Don't think that for a second. Your priority is accuracy. Accuracy and only accuracy. I don't want you saying I don't want to make sure I get the right answer because I want to do the problem faster. Go back to that car mechanic analogy. You don't have the luxury if you're a mechanic to sometimes fix the car. You don't have that luxury. It has to work every time. There's no B, there's no C+. It's an A or you don't get paid. It's right or nothing. So here we go. Now, he wrote this word down, of course, so I told you to copy everything. He wrote the word attic. Go ahead and make the A much darker. Make that A really dark. Same thing with the C. Make that really dark. Make the A and the C darker. And the reason we're using that word is not just, well, attic is on the top, so we call it that attic. It's because it has the letters A and C in it. They correspond to this. The first term is always A, the last term is always C in your trinomial. And trinomial is 3, right? So it's always going to be an A, B, and C. So what goes in the attic? It's A times C. A times C. So 2x squared times 10, 20x. And then B, make that B, the basement, darker. That stands for the remaining term right here. That's what it stands for, 9x. So here's what we're doing. We're taking 9x and we're splitting it up into two numbers that add up. Those two numbers are going to go here. We can't just plug in 9x here and start factoring because we're missing. So that's why we're going to take that 9x, use this tool, to break it up into two parts that will factor. And you might remember this. We're trying to find two terms that multiply to 20x squared that will multiply to the attic, but add to the basement. You have to add. So what numbers multiply to 20, but add to 9? Think about it for a second. Numbers multiply to 20 and add to 9. And you get 5. 4 and 5. Either order does not matter here. Is this complete? Does 5 plus 4 equal 9x? No. So let's don't get the x. So 5x times 4x equals 20x squared. 5x plus 4x equals 9x. And those are the same as 9x. 5 and 4 are the same as 9. What I've done is I took this trinomial, and now I have 4 terms which will fit in the box, just like we used to. So the purpose of that whole attic basement, the whole x, is really because, well, I only have 3 terms with 4 boxes. I'm going to keep the first and the last term the same, but that middle term, 9x, I'm going to turn into 5 and 4. And I have to use 5 and 4. You can't use 7 and 2, it doesn't work. Can't use 6 and 3, it doesn't work. You have to use certain numbers that will work. And now, just like we have been, go ahead and factor. So what's the GCF of the first row?
2.
2 for the number. Any variable? X. Then we can do, what's the 2x times what equals 2x squared? 1x, which is x. You notice how we did that, or we could just say, what's the GCF of this column? There's no numbers in common except for 1. I do have a variable. The 1 is optional, we don't have to put the 1. Once again, we can either find the GCF of this row, or we can say x times what is 5x. And you get the same number. So the GCF is 5, and also x times 5 is 5x. Lastly, we can do the GCF of this column, or we can just say 5 times what is 10. So you get the same answer. So our final answer is 2x plus 5 times x plus 1. So if we went through and put this back into the box, like we did last week, we did this whole process, but those right here and right here, we'd end up with the problem we just started. The question would be our answer. So you can always check if you want to check even one more time to see if you got it right. That's the process. Now we'll show you some subtleties that you'll run into. Let's practice on these two. Go ahead and write both of these down. Both x's. I'll show you some various difficulties or differences that you might run into. Write it down. Write it down. And then if you want to, go ahead and start. On the left one, what two numbers multiplied negative 28x squared add to negative 3x? See if you can find those numbers. Now this first one is the easier of the two. Second one is a little bit more involved. So when you think of 28, what numbers should come to mind? 7 and 7, 4. Can you use 7 and 4 to get to 3 somehow?
Yeah.
Yeah. So 7 and 4 are going to be correct. I always say get the numbers up there, and then you can figure out the positive negatives, right? So, and we're going to say this is 7x and 4x. Now, we know that these don't multiply to negative 28. They don't add to negative 3, so one of these needs to be a negative. Which one?
The bigger one.
The bigger one. So you have a choice. If the negative was on the 4, it'd be 7 minus 4, which is positive 3. So that means the negative should be on the 7. 4 minus 7 is negative 3. And of course, they both multiply to negative 28. So it does make a difference where the negative and positive go. So again, that's the easier of the two, because when you see 28, the first thing you think of is 7 and 4, and those are the correct numbers. Now let's look at the next one. What's the first two numbers when you think of 45? 9 and 5. Now, is 9 plus 5 or 9 minus 5 18?
No.
No. So 9 and 5 are not the correct numbers. So this is when you might have to do a little bit more. So we have the regular times table numbers, you know, like 45 is on the regular multiplication table, 9 and 5. But we could have numbers bigger than that. So here's what we can do. You can either do more trial and error, if you can just try to figure it out, or take the numbers you do know, 9 and 5, and you do these little factor trees. You break it down to when you only have prime numbers. So right now, you're using 5 and 9, which is 3 times 3. What you can do is associate them differently. So you take the 5 that we had by itself and one of the 3's from the 9. What does 5 and 3 make? 15. What are you left with? 3. Does that make 18? Yeah. So it's a little bit better way than doing a trial and error and just, well, is it this and this? Is it this and this? That doesn't work, that doesn't work. Here you can just use various combinations of the prime numbers until you get 15 and 3. Alright, so again, we got 15x and 3x. Are those the right numbers? No, almost there. Why are these not the right numbers? Yeah, it's negative 18. If this is a positive 18, this would be correct, but it says it has to add to negative, so it's both negative. Notice how when they're both negative, it still multiplies to a positive. So it's okay if they're both negative, you still multiply to get a positive. Okay, that's a big point for maybe a few of you in here. Let's see if you know your rules well. Do two negatives make a positive?
Yeah.
Yeah, sometimes it's the correct answer. You don't want to say yes, you don't want to say no. So some people say, well, no, that's not right. You get that's negative and negative is a positive. You should have positive 18. Not true. So you have to know what rules apply in what situations. Two negatives make a positive if you're multiplying. Two negatives make a negative when you're adding and subtracting. So think of the two negatives making a negative as you borrow $15 from one friend and $3 from another friend. Negative numbers are like borrowing. Altogether you borrowed 18. Negative number. It's not like as if you borrow 15 from one person and 3 from another person. Now somebody owes you 18. It doesn't become positive all of a sudden, right? So keep that in mind. Don't mix up your rules because this could be a little simple distinction that can mess everything up if you're not careful. So it's always two negatives make a positive going up to add it, but two negatives are a negative in the base. So we'll practice a few more, and we'll get started. Let me show you just right here. Just watch it. Watch me up here. I just want you to see at full speed. I know some of the stuff is already written for me. But eventually you want to get to this speed. Eventually you want to get to this speed. Draw your X, draw your box. Put the first term and the last term in. Make your at 15x squared. Make your basement 8x. This is one of the easier ones because 15, the first thing I think of is 5 and 3, and I have to add up to 8. So I get those two. I'm going to put those two right here in the box right away. Either order does not matter. Start doing the GCF, multiplying. And this is the speed you'll eventually be going at. So each of these problems is less than a minute. I'm not going to start off this fast, but eventually that's what you're going to get to. Now, of course, there's some people that you can get to 3 and the 5. And if you can do the factoring and get the answer without the box, then you can do that as well. Let's have you guys go in and try this. Write that down. Write down the X. Write down the box. Use the examples on your notes already to help you fill in information to start off with. And then use your notes, or if you know how to do it, just go ahead and finish it on your own. Check with someone when you finish to make sure you get it right. Again, I reiterate, do not stare at it and say, well, I can do this in my head, I'm not going to write anything down. I just happen to be retaking this class by choice, not because I have already failed it. Okay. You have to remember, if you have a method that you've used before, it may not work as well as this one. Don't want you just saying, okay, I can just leave off this part, I'm not going to do that much writing, because I want to hurry up to finish. Whether or not I get it right or wrong doesn't matter. Okay. Switch priorities to accuracy. Not hurry up and finish. You impress no one, especially myself, when you're the first one that walks up, turns in your test, and you have a half hour left in your class. Tells me you don't care, you have not trying your hardest. And you can do better, but you're choosing not to. Tells me a lot of things. Someone that keeps the test until they check everything, done work for everything, Then I know you care and you're fine. Check if you've done all the work. Yes. If you've just done it once and did no checks and showed no work, no. Not impressed with you. All you did is write an answer down. You all due respect? Of course, I do want you to check, but I want you to write an answer down and say, okay, I wrote it and done. If it's not correct, it doesn't count. So check, make sure the work is the same, almost. Some things can be switched. That's okay. If not, help each other out. Okay, yeah, oh, right. So draw your box. Like I did before. Draw a knife, draw a box. What goes on top? What goes on the bottom? Same thing we do. How did I get 20? Do X squared. Do X squared. And on the bottom, what goes on the bottom? Do the same thing. Those okay, I see a lot of boxes. Usually match as well. How do I get those numbers? So waiting for some to finish the box. Here we go. Watch up here, please. Follow along with me. Each of these problems, I'm going to have equals and answer. I'm going to start off by recognizing there's a trinomial. When there's a trinomial, that's how I know I need to do all this work. And I need it for box. Each of these problems will have this work. Alright, set it up. 6k squared, positive 8. What goes on the top? What goes in the attic? ABC. That's going to be 48. K squared. What goes in the basement? 19. Now I chose this one because it's not the first choice number. So 48 you think of 6 and 8, but 6 plus 8, 6 minus 8, that doesn't give you 19. So we're going to go 6 and 8. 6 is the same as 2 times 3. 8 is the same as actually 2 times 2 times 2. If you want to do 4 and 2 and then break 4 into 2 and 2, that's fine, but 8 is 2 times 2 times 2, that's okay as well. And we're going to try some different combinations until we come up with 19. So we could try 3, 2 with 2. What does that make?
12.
12. And what's left over?
4.
2, 2 would be 4. 12 and 4, that doesn't make anything. Okay. So let's try something else. Let's try all the 2's. 2, 2, 2, and 2. What does that give you?
8.
And what's left over? And that makes 19. So you can see you can get, just by playing with different combinations, this way you're not trying anything that does not multiply to 48. No matter what combinations you choose here, they all multiply to 48. You're just trying the right combination in order to get to 19. Alright, so we're going to do 16k and 3k, both positive. And then put those same 2 terms right in here. 16k and 3k, both positive. GCF of the first row. What number?
2.
2. Good. And what variable?
10K.
Okay. All right. And we can do GCF of the column, or we can say 2k times what is 6k squared?
3.
3k. Good. 3k times what is 3k?
1.
Positive 1. What's the GCF of this row? What's the GCF of 3k and 8? 1 as well. So when they don't have anything in common, you can always use a 1. And lastly, what is 1 times what is 8?
8.
You get plus 8. And of course, put your answer right back up top. So next to each question, you'll have equals and then your final answer. You're going to have all the work right below it, though. It does not matter which order you put these in. It did not matter which order I put 16k and 3k. You could have put 16 on the bottom, 3 on the top. You will get the same answer. All right. So this is the work I expect to see for every problem. Please don't show up tomorrow and say, but I did this way, and now I'm missing 4, 5, and 6 are all wrong, but I did it my own way. Remember, going for accuracy. Put your own wants behind you and put, I need to get all of them correct.